Welcome to this Stockbox interview with Mike Moles, the non-executive director of Kavango Resources. Hello, Mike, and welcome.
Yeah, good afternoon.
How are you doing?
Yeah, fine. Thank you very much.
Good. So, Kavango have been carrying out some 3D geological modelling, and you announced today some initial images from your Kalahari Suture Zone project
Mhm.
in Botswana. And in the RNS, I noticed that Kavango's CEO is quoted as saying, "The images are quite spectacular and potentially transformational." So, could you explain, first of all, why?
Yeah, sure. Look, I think that we didn't quite know what to expect with this 3D imagery. We hadn't done this type of thing before. We engaged the services of Mirror Geoscience, who are probably the world's leading experts in this type of 3D imagery. And to begin with, it didn't look as though it was going to work. I think the main problem was that at the KS said there are two levels of gabbroic intrusion. One is about 1 billion years old, and the other one is much younger, and they sit one on top of the other. So when you first look at the imagery, the two get sort of jumbled up, and it's quite difficult to see what's going on. Later on, they were able to separate the two gabbros. I mean, they look very similar to each other, both gabbro, despite the fact that they are very different in age. They have very different magnetic characteristics. So that was the way in which our geophysicist working with Mirror Geoscience was able to separate the two generations of gabbros. And so we've now suddenly we can now see these gabbroic sills in 3 dimension from all different angles in isolation from the much older gabbros, and we can really see what's going on for the first time. You'll appreciate that everything is covered in sand on the surface, so you can't see the rocks in hand specimen on the surface. So being able to view these gabbros in 3D below surface is amazing. And I think that's why our CEO was sort of bowled over by the imagery.
Mm-hmm.
And we then were able to compare what we were seeing on the KSZ with some of the gabbros that were mineralized at Norilsk, and they looked remarkably similar. I mean, it has that same sort of morphology. And if you look on the website, you'll see an example of the gabbros or a schematic of the gabbros from Norilsk compared to the gabbros that we're finding on the KSZ. And they do look remarkably similar, and we're very excited about that. Everything else is beginning to sort of fall into place. We've got gabbroic sills intruding into coal measures, which have a lot of sulfur in. We know that the sulfur was incorporated into the molten magma, which is exactly what happened at Norilsk. We know that the sulfur combines very well with the copper and nickel in the gabbroic melt, and will extract the copper and the nickel and form a what do you call it? A magmatic sulfide liquid, and that liquid, being much heavier than the silicate liquid, would gravitate towards the bottom of the sill into what I describe as being the keels of the intrusions. And this is what we now see from this modelling that we've done. And of course, the other great thing about it is that all this has been done remotely from the deposit. So the COVID problem hasn't really affected any of this at all, because we had all the data already. So it was just a matter of compiling really what was a huge amount of data from the drilling that we did, drilling that other workers have done over the years, all the magnetic data, all the EM data, and so on. All this thousands and thousands of data points have been put into this program to produce these remarkable images.
So I think it's worth maybe explaining to people listening where they can find the images on the website and have a look for themselves. Can you explain where they are?
Yeah, sure. Well, if you go onto the Kavango Resources website, there should be a section there called Projects. And if you look on Projects, you'll see the KSZ, Kalahari Suture Zone. And under that, if you click on the KSZ project, you'll see those images which can be clicked on. And you'll be able to see how, obviously, what you're looking at would be sort of two-dimensional views, but they are taken from a three-dimensional model.
Okay, so I've got them up on my screen now, and I remember seeing the 2D graphic that Kavango produced, and they look remarkably similar. So you must be pleased then that the 3D, which is compiled for more data and you can see a lot more information, is similar to what you theorized was in fact down there.
Yeah, I think so. I mean, it's look, I think that's what's so exciting about it, is that we've sort of been predicting this, for quite a long time, and but it's always been difficult to see it. We haven't done a huge amount of drilling ourselves. We've used a lot of drilling that's been done by other workers in the past, and it's great to see all these coming together. If you look on that view, you'll see a plan view, which is a lot of green blobs in a sort of square box. Those are the Karoo gabbro sills. You'll see there the one at the top, which is about 6.5 kilometers wide. So that's a fairly substantial sill. And then you can see what that looks like in section view. And you'll be able to see how the keels of those sills are deeper than the flat-lying sill, or the flat-lying, what I call gull wing parts of the sill. The deeper parts are the parts which are most likely to contain the massive sulfides, because the sulfide liquid, being heavy, will run down in whilst the magma is still molten into the lowest part of the sill, and that's obviously what our target is going to be.
Okay, and you mentioned Norilsk a fair bit. How significant is it that the deposit that Kavango have on the Kalahari Suture Zone resembles the Norilsk project?
Well, look, I mean, when we first looked at this some years ago, I think that we initially thought, wow, this looks very much like the Norilsk story. The Norilsk story is really about the gabbroic magma intruding into coal measures, and the coal measures providing the sulfur necessary to precipitate the sulfur, and that's what got us onto this thing in the first place. So I guess that the Norilsk model has always been in the back of our minds. Look, there are lots of other similar deposits, like Vosis Bay, for example. There's a couple in China. There's one in India, and I think a couple more in Canada, which all have a sort of similar morphology. And the reasons why there is sulfur in the magma is variable, but obviously one of the most favoured sources of sulfur would be where the magma intrudes into coal measures, which is exactly what we've got. We know that the Karoo sediments contain quite a big formation of coal measures, which includes proper coal seams, but also a lot of sort of coaly shale. All this material is packed with sulfur.
Okay, and what makes the Norilsk deposit desirable? What are its key attributes?
Well, I suppose the biggest attribute is that it's probably the biggest single mine in the world. It's definitely the biggest producer of nickel and palladium in the world. It's an enormous mine, actually a series of mines, and its geological setting is very similar to what we're seeing on the KSZ. So we not only do we see the morphology of the sills looking very similar, but also its position, its sort of tectonic position on the edge of an ancient craton, is one of the hallmarks of this type of deposit.
Okay, so that must give you quite a degree of confidence in the KSZ then.
Yeah, absolutely. Yeah, and I think this is what sort of keeps us going. I mean, we haven't yet come across anything that's sort of a no-no. There's nothing. There's no fatal flaw yet. And it's difficult now to see that there would be any fatal flaws. I mean, we think that, I think that's why this is so significant, that we are now looking at something that really could host very large, massive sulfide deposits. So it's really very exciting.
Okay, so what's next then for the exploration?
Right. Well, I think that so we're going to go through all of the sill. We've chosen the Hukunsi area because it has a large density of sills. They're all well preserved, and so we sort of windowed out that area. There are a few problems with some of the ground to the south. Some of it's in national parks and so on. So we have to sort of start somewhere, and I think that the Hukunsi area looks like the area that's most interesting. It's also the area that we've done the most work on. So what we're going to do now is we're going to go through all these sills very carefully and choose 5 or 6 that have exactly the right sort of morphology. Keep on going back to the Norilsk model and say, okay, what looks like a typical Norilsk ore body scenario. We'll choose 5 or 6 of those, and then what we want to do then, before we go to a drilling phase, we want to do some quite sophisticated ground EM surveys. It's a geophysical survey, which hopefully will pick up mineralization at depth, because what we want to find is those areas that we think are likely traps for the magmatic sulfides to be accumulated in. If we can find some of those that have return a very clear conductive signal from the EM, it's unlikely that it could be anything other than massive sulfide mineralization. So we would then target those. And so perhaps out of 5 or 6, we may pick 2 or 3 if they have significant looking conductive zones within them for a drilling campaign. So I guess we would be looking at that sometime next year.
Okay, well, Mike Moles, the non-executive director of Kavango Resources, thank you very much for talking to us.
You're very welcome.
Thank you for listening to this Stockbox interview. For more information, interviews and videos, visit our website at stockboxmedia.com or give us a follow on Twitter by searching @StockboxMedia.